Welcome. So, I'll kick today off with a story. I feel like a lot of big things have been talked about, large language model. This is a story, just two small things, two Booleans. Also, a nice little primer about how clinical laboratory gets your test results to you. Since I'm always very lucky to get the after lunch nap time slot, we'll do a little bit of interaction so that you stay awake. So, clinical laboratories perform tests on specimens from patients, usually with the intent to provide diagnosis or assistance with a treatment decision. Some labs will have a really broad range of tests, your complete blood count, your cholesterol. Others will be very narrowly specialized, cancer, rare diseases. Regardless of specialization, all lab processes break down into the same set of domains. A lab will get a test order from a physician. It'll then obtain a specimen from a patient. It'll put that specimen through a testing method. It'll create some results, which, if they're flagged, will have to be reviewed. It'll generate a report, ship that back to the physician, and bill for services rendered. So today's story zooms in on two domains, and that is result creation and report generation. The responsibility of result creation domain is to detect and quantify a piece of data. What's my cholesterol? What's my blood count? In case of a cancer test for an oncology patient, we examine a set of genes that we call a gene panel, and we look to detect mutations in them that have clinical applicability, so they have targeted treatments or clinical trials available for those patients. The results come out in a tabular format. You can think of them as an Excel spreadsheet. And in those, the results, the mutations are either detected or not. Those results then go to report generation domain, which has its own set of responsibilities. It will enrich these data from external sources. It will replace controlled vocabulary with something human readable. It will sort and filter down to those clinically actionable mutations, generate some nice graphics, and package it up into a report that goes to the physician. So in short, a result creation domain detects a mutation, and report generation domain will sort and filter through the detected mutations to select the ones that are important to put on the report. And thus detected is our first Boolean, and this is the first version of a test that goes to market and is successful. Of course, nothing sits still. Scientists do more research. They come up with a bigger, more expansive gene panel, which they will creatively call V2. There's a big overlap with V1, but we're working with a constraint. And the constraint is we cannot change how our V1 test is operating. It's on the market, patients have used it, it's been approved by a regulatory body, can't change it. So, and we still need a way to distinguish which mutations go on V1 report versus V2. So we need a good way of separating those two out. In comes our second Boolean called reportable. We made an agreement with result creation domain to identify mutations that are for V2 panel and that might be reported on a V2 report. Okay. Can't change V1, so that continues to use detected, and a V2 report is starting to use a combination of detected and reportable in order to find the right mutations there. That is good. It goes to production. A year and a half later, however, somebody in the result creation domain is saying that not all results that should be showing up on the V2 report, in fact, are. We start looking into it. We walk through the behavior of both V1 and V2, and we examine the intents and the actual implemented behavior. What do we find? So for V1, the result creation domain intended the report generation domain to use detected. It does, so we have parity. For V2, however, the result creation domain really intended it to only use reportable. But result generation domain is using a combination of detected and reportable to find V2 mutations. Okay, so clearly not parity, but what's the impact? What happens actually? Well, we borrow a page from our test team, we plug in our Boolean values, and we start looking at the results. And what we find is that with their values of detected and reportable, in most cases, they produce consistent behavior between what result creation domain intended and what report generation domain implemented, except for this one case. And it's an interesting case because this is not a 25% case scenario. This is human biology, mutations are mutations. This is maybe 0.01 case scenario, 0.01% case scenario, the way the real data lays out and why it went unnoticed for so long, but nevertheless, can be considerable implications there. So, of course, arguments between two domain leads ensue, and I am that guy on the right saying that the system is behaving as designed, and you probably know what the answer to the question on the bottom is. It is. So we do some confluence archaeology, dig up some page, and all agree that it does not sufficiently describe either the problem or the intentions of the solution. So now comes our first interactive part. Why did this happen? How did we get here? And by the way, you're welcome to yell out loud. I'll repeat it. Someone made an assumption. Good. Say that again. We tried not to go that way. We said, no, it's not the other team's fault. Go ahead. Not enough test coverage is a real interesting one. And I will tell you, we do a lot, but it's really difficult with human biology because creating that test data is something else. All right, so let's go through this. We are at Domain-Driven Design Conference. Everybody knows the importance of ubiquitous language. We had some incoherent naming. So detected, reportable, what do they really mean? Maybe not super clear. We had some unclear intents. One domain intended something for the other. Did it communicate it properly? Probably not. Definitely no versioning strategy. When we started out, didn't know how that was going to go. Maybe some fuzzy domain boundaries. Maybe one domain is doing something it best should be left to another. And we have knowledge leaking across domain boundaries, which has to do with those fuzzy domain boundaries. So all of those are reasons, but what stood out to me as the biggest one and a common theme to all of these is we didn't have a clear and documented decision on the behavior of the V2 system. So small thing, 2 Booleans, can be really big implications. So some time ago, I defined the role of an architect as a leadership role, and the leadership is in 3 different areas. It's people leadership, it's technology leadership, and it's thought or innovation leadership. If that's the role, and feel free to use that at parties when somebody asks you what the role of a software architect is, what is the job of a software architect? There are very divergent job descriptions, but what do they actually do day in and day out? You can yell that too. Sit in meetings, that's a good one. I call it synthesize information. Nobody said draw diagrams. Somebody had to have gone to the visual communication workshop, so do a lot of that. But one of the biggest things that architects do with good frequency is they make architectural decisions. It's a very important skill to develop. But why are architectural decisions important to spend next 40 minutes on? Say that again? How long the decision will impact? Yeah, the duration of the decision has something to do with it. You're leading up to an important thing. Anybody else? So the reversibility of the decision. How costly it is to change your mind? How costly? That's a very key word, yes. Yes. Communication? Business impact of the decision? Okay, now let's go through my answers. So decisions can manage unintended consequences, kind of like the one we just saw in an example. They can impact your quality attributes or your abilities. They can affect your system's ability to change. They can resize your technical debt. And if you're listening to the verbs here, they're all very neutral without any value judgment. Decision can resize your technical debt. Your decision can make it bigger, can make it smaller, and either one of those might be the right decision at a time. They can even change your career trajectory. You make good decisions, you get promoted. You make bad decisions, you get fired. Sometimes it's the other way around. But really, the reason why architectural decisions are important is because they directly inform the long-term cost of a system. Your decisions, your half decisions, your indecisions all have long-running implications, and we have to deal with those implications and their cost. So under those circumstances, who even wants to make architectural decisions? They sound very daunting and dangerous, and there's consequences. And they are all of those things, I promise you. But there is good news. First, decision-making is a skill, and as a skill, it can be taught, it can be learned, and it should be practiced to get better. Second, you're not doing any of this alone. If you are, you're probably doing it wrong. There's a group of people you engage with at every step that helps you through that step and gets you on to the next one. Last but not least, with architectural decision-making, like with everything else, you get better results if you go through a consistent process. A framework or heuristic will give you that consistency and help you make better decisions over time. Worth saying that no framework's going to be perfect, but it will help you avoid a lot of common pitfalls, and that is exactly what I'm here to talk about today. But before we get too deep into it, this is me. My name is Sonya Natanzon. I lead engineering teams. I architect. I'm a healthcare specialist, as you already heard from the examples. I love when people get in touch with me. LinkedIn is always a good way to do that. And this is a word that describes me. I didn't invent it, but I thought it was a cool word. I tend to break down complexity, hard for me to deal with it, to the point when it's manageable. So without further ado, let's decomplexify architectural decisions by breaking them down into 8 steps, starting with the first one, which is formulating a problem statement. How many times have you been in a room where there's engineers arguing about technology? We need to migrate to the cloud. We need a document database. We need Kafka. And you're sitting there wondering, what problem are we trying to solve? So engineers are detail wranglers. This is their job. This is what they're paid to do, is to go deep and solve those problems. But when you go way deep into the weeds, I tend to lose the bigger context and overarching objective. So before you go and engage with any solution making, formulate a problem statement. That is a first and foundational point of any decision making. Why? Because problem statement gives you a clear goal. It gives you a North Star to which the solution should be aiming toward. And it gives you a way of questioning the solutions with, how does migrating to the cloud, getting Kafka, or anything else help me with my problem statement? Charles Kettering, who was a head of research at GM, once said, a problem well stated is a problem half solved. So how do you state a problem well? I borrowed this very nice little heuristic from Seth Dobbs, and a problem statement should have one of 2 things, either good outcomes that aren't happening or bad outcomes that are. That's it. That's all it should have. And we can try this out right now. Here's one. We're losing $25 million annually due to bad billing practices. Has a bad outcome that is happening, makes it pretty clear where you want to go from here, which is stop losing $25 million annually or get down to the number that we're willing to live with collectively. Gives you a clear goal, gives you a way of questioning your solution with, how does this solution help me with my $25 million loss? Here's another one. We need a new billing system. My knee-jerk reaction to a statement like that is, why? Why do we need a new billing system? what good outcomes will start happening or what bad outcomes will stop happening if we get a new billing system? Unclear, other than we'll have a new billing system. So what do we have? Well, this one is pretty clear. This is a good problem statement. Do we know what the solution is? Is it a new billing system? It could be, or it could be a retrofit of an old billing system, or it could be something else entirely. The point is, we have an outcome to achieve, and we're free to go and explore solutions toward that outcome. And what about the second one? You guessed it, this is a solution in search of a problem. And if that's what you're finding yourself with, stop. You probably don't have an architectural decision to make. You're being handed a solution as a foregone conclusion. I don't know why, maybe it's your boss's pet project, maybe it's something else. But there's no outcomes to reach. It's, it's already a self-packaged statement. Not a problem statement, but a solution one. So, you have a heuristic for problem statements. Now I'll show you one for solution statements. Pretty much anything that's going to start with "we need" is likely going to be a solution statement. You could try this. We need to migrate to the cloud. We need to use microservices. We need AI. All of these, it's hard to get anywhere. It's really hard to be successful here because it doesn't really work as a problem statement. You can still try to get to a problem statement from here. You can try and peel back the layers, ask a lot of why questions, but ultimately, if you can't get to some kind of outcome, stop. It's going to be very, very hard to be successful if all you have is a solution in search of a problem. AI. All right. All right, so I did say you're not, well, before we go there, this is a long time to spend on the problem statement. And I do recommend you actually spend a long time on the problem statement. You're going to need it throughout the life of the decision-making process and any project that surrounds it, and there is more often than not a project that surrounds it, and you'll need it for 3 reasons. One, justifying the existence of the project and any resource requests that you might need, engineering hours, budget, tooling, all going to be justified by the problem statement. 2, you'll need to use it to validate any assumptions and constraints with your stakeholders and any other supporting information. And last but not least, you're going to want to keep it as a shiny, shiny North Star for the engineering team so that they don't get distracted by any other shiny things. All right. And I did say you're not doing any of this alone. Who are you working on the problem statement with? Well, your customer or anybody who proxies for the customer for you. Is it a product manager? It could be a support engineer. It could be an account manager who does onboarding. Any of those will help you with the problem statement. For more technical projects, in decisions, which we all know we have those, despite what we say, you're working on this with a lot more of the engineering groups, extended engineering functions like DevOps, and so on. So now that you have your problem statement, is it solution time? Not yet. Before we get to the solution, we need to identify our last responsible moment. In other words, you're asking yourself a question. When do I need to make this decision by? But why even ask the question? Why not make this decision whenever you want? After all, you're the decision maker. Why not make it immediately? Decision time is always short. Project time is way too short. We want to make progress quickly. Well, early on in the decision-making process, you have limited information. Information accumulates over time. It also happens to change over time. So some of the early assumptions that might have been made get invalidated. They get replaced with the new ones. So any decision made early is going to be hugely risky and very likely will get reworked. That means longer timelines, larger costs, more unhappy business people. Well, in that case, why not make the decision when you know absolutely everything to know about this decision? When is that, by the way? When you're done, yeah. Never. I actually asked this question once and somebody yelled out, never. I'm like, yeah, kind of. But at the end of the project, you frequently get to the point where, well, you know enough, you have some hindsight. Your information is stable, it doesn't change, but somewhere along this time axis, you're going to start running out of time until it eliminates all of the important alternatives for you, leaving you with only one, the one that fits into the remaining timeline. So the decision gets made for you by default. And the decisions that are made by default are rarely the best ones. In fact, they're typically ones that have a very long maintenance tail or sometimes even complete rework. So a different way of asking when do we need to make this decision by is asking what alternatives do I have to consider? There are cases when there might be none, usually when there is one really dominant constraint and it pushes you to one option and that's the only one acceptable. But more often than not, and in case there aren't alternatives, skip to step 7, record your decision, you're done. If there are, you still need to find your last responsible moment. And the last responsible moment is a technique of delaying decision until the moment when the cost of deferring decision is equal and about to be greater than cost of making a decision. What does that mean in real life? Let's say you interviewed for a job and you got a job offer. That thing comes to you with a very convenient last responsible moment, and that's the date by which you must accept or decline the offer or the offer disappears. Do you want to make that decision immediately? Probably not. You want to make a very informed decision, so either negotiate for more money with a new company or maybe get a counter with the current company, or maybe you're waiting for that really annoying colleague to put in their own resignation. Regardless, you're trying to make a very informed decision without eliminating the alternative of having this job on the table. It's the same in software. You're trying to delay commitment until the moment when this delay is going to eliminate an important alternative. Basically, making the most informed decision possible while keeping your options open. That plays out in build versus buy all the time. If you're about to invest into something expensive, a new platform, a new framework, you want to take the time to evaluate it, make sure it fits your use case. It's not going to be a huge cost to operate it when it's running. But you don't want to wait so long that once you decide on it, you don't have time to implement it properly. So what really is your last responsible moment? It is the first and biggest constraint for you to identify. It is also a convenient mechanism to surface all other constraints that you might have and their relationship to each other. If you notice, we almost never talk about a single constraint in isolation. All these things, timelines, budgets, long-term business objectives, available engineers, quality attributes, they all interplay with each other and relate to each other in some way, and they all need to be considered in the solution. I personally love working with constraints. Constraints help precisely because they eliminate options. It is really hard to be in a wide open field and pick a direction. Constraints help narrow that path. But the relationships of constraints to one another can be really complicated to elucidate. It always reminds me of a Rube Goldberg machine where you press here, something over there falls down. Can you have more security for less performance? I don't know, figure it out. But you do need to have all of these constraints on the surface. So, coming back to our problem statement, we've now worked with our stakeholders to surface out our last responsible moment, highlighted here, 6 months, probably important, and all the other constraints that we have to consider in our solution. So now that we have this, and we know the moment hasn't passed, is it decision time? Is it solution time? Not yet. Before we think of any solution, we need to think about a criteria by which we will evaluate that solution's fitness to the problem statement. What will we deliberately consider, and what will we explicitly ignore? I sit in on a good number of design discussions, and the question that I always ask is, why is one option preferable over the other? And the answer I get pretty often sounds like this. Well, this one's more performant, and that one reuses code. And I don't know about you, but it doesn't help me figure out which one fits better in this case. Is performance and code reuse both important? Are they both important? If so, why aren't we considering them for both options? If they're not, why are we considering them at all? So before you start on the solution, identify the criteria that you're going to use for evaluating your solution across the board so that you don't have this apples to oranges comparison happening. These criteria will fall into 3 different categories. One is, how well does it solve the problem? And I know this sounds really basic and obvious, but you'd be surprised how many I've seen that don't solve the problem either in part or at all. Second one is, how well does it address the constraints? And last but not least, how well does it satisfy the quality attributes? Quality attributes are constraints in their own right, but they're not the constraints that are going to be given to you by the business. If you ask the business, do you want your solution to be secure and performant? What are they going to say? Yes, of course. How performant, how secure, that you're going to have to help them figure it out, or help yourself figure it out and make some proposals. There'll be other quality attributes that they won't know what they even mean until you put them in the business terms. What does that mean for code to be maintainable? Oh, it means we don't have to hire 2 more support engineers next year so that they sit on the phone all the time? Great, let's work on that. Not all evaluation criteria is going to be made equal. Some is going to be more important or more rigid. Regulatory constraints fall into that category. Others are going to be more flexible or just less important. How do you incorporate that into the evaluation? I use relative weights to indicate that importance and rigidity. The higher the weight, the more we need to consider a particular criteria. So we come back to our problem statement of losing $25 million, and we came up with a set of criteria by which we will evaluate all of our solution options going forward. And you can see the relative weights in there as well. So now that we've got our criteria for evaluation, is it solution time? Yeah, we're at solution options. And I know this seems like the most important part of this, but this is actually the one I'll spend the least time on. Why? You're all engineers, architects, you know your domains best, you're eminently qualified to come up with right solutions. A couple of things to remember as you do so. First, generate more than one option. Your peers, your boss, your customers will definitely want to know that you've considered more than one option, not just your favorite one, not just the first one that popped in your head, more than one. And it's possible to come up with them. I was told this once by a very sharp product manager. He said, if you can think of one, you can think of more than one, because the first one always sticks the longest. Don't go too far beyond 3. 3 is kind of a magic number. You can go a bit above that, but anything more than 5 will be analysis paralysis, and people will get lost in nuance. What starts happening with too many options is you also develop these variants. You get 1B and 3C and so on. This is a good time to start doing work of elimination and just prune the variants that aren't viable. Some of them will replace the main options, others will go away, but keep it to a manageable number. Very importantly, try to come up with at least one radically different option. I find that this exercise is very useful to keep yourself out of your own and somebody else's bias. Maybe you had a favorite technology that you had in mind. Actually, I am sure you had a favorite technology in mind. Maybe your boss is pushing a vendor that they worked with before. Having a radically different option helps with just getting everybody back to the table and considering this from very, very different angles. And you're doing this work with your peer architects, engineers, and occasionally the business. So we come back to our problem statement, and we now have 3 solution options. We have our new billing system solution, we have retrofit an existing billing system solution, and we have one radically different option. Notice it's not even a technology solution. We don't write any code here, we just train some people, get a new role, and we think it's going to help us with that $25 million loss. Now that we have some options, is it decision time? Before we decide, we need to get some advice. And this is where I'm going to feel like I am repeating myself. So I made this step, come back to it, I made this step separate and linear, but in reality, getting advice is kind of mushed together with solution options. As you're creating those options, you're probably going to seek advice, and this is how you're going to either eliminate or keep them. So it's not a super separate step, but it's worth calling it out because there's enough to it. A reminder, this is your decision somehow. Either your organization empowered you with this decision, maybe you're an accidental architect and it fell in your lap, but it's your role and responsibility to make it. Second reminder is those decisions have consequences, and you're responsible for not just the decision, but its consequences. Daunting, but good news is you can and should get some advice. Advice is not like input. That tends to be very authoritative, and people seem to think that you've ceded the decision to them. It's not like feedback necessarily. Feedback can be very generic because the question, well, can you give me some feedback, is also generic and non-specific, and it's hard to not give leading questions. When you ask people for their lived experience, you tend to get a lot more useful and nuanced input. Who do you ask? You ask 2 groups. Those who are meaningfully impacted by your decision. Maybe it's an engineering group that needs to consume the API changes. Maybe it's a support engineer who'll have to explain the new UX to users. Maybe it's a marketing person who needs to develop new promo materials. The second group to ask is those with expertise in your design space or in your decision space. Essentially people who have done this before, maybe stepped on a few landmines, maybe avoided a few others, live to tell the tale. The list of people to ask can get long, and this should not be scary. It just indicates the importance of the decision. If it's a small decision, not a lot impacted, should be a short list. Don't shortcut the process. You don't want to be that person who repeated a mistake that's already been made and is known, or the consequences of your decisions can't be consumed by some group because you forgot to ask them. What do you do with all the advice that you get? The beauty of advice is you don't have to use it all. You don't have to incorporate it. And some of it won't be applicable. Maybe this person with expertise in your decision space, maybe they were working on a shoestring budget and a long timeline. Your situation is the opposite. So sometimes circumstances are different. But you do need to do a few things. First, you need to seek a broad range of inputs. Do not be looking for that confirmation bias of the solution that you already like. Do ask people who may have very differing opinions, as much as you don't like it. 2, you need to process it and understand where it's applicable and where it's not. Don't just dismiss it. And then you just need to record it with that justification. That's it. That's all you really need to do. And what I described here is not my invention at all. This is Architecture Advice Process by Andrew Harmel Law, who, if he doesn't have a book out yet, I know he will soon. I do highly recommend you look into it. There's a lot more to it. This is just a super condensed version of it. I like it because It keeps the agency of decision-making with the architect, but it does force you to actually look around for that advice. So now that you've been advised, now what? Is it decision time? I see thumbs up. Not yet. Not yet. Before decision, we do need to perform our trade-off analysis first. The good news here is you pretty much already have everything you need for that trade-off analysis. You have your criteria, you have your weights. Now all you have to do is give yourself a scoring system, and that can be totally arbitrary. Make it 1 to 10, -5 to 5. And then you have to go through and score your solution. Not just score it, but give a justification for why you gave it that score. This is an interesting part of the process because this is where a lot of debate happens. And what happens as part of this debate is you frequently end up re-evaluating your criteria weights. Ooh, I thought my budget was flexible and I could ask for more money when I need it. Turns out it actually isn't, and I need to fit into that number, so it's a lot more rigid. If you remember our problem statement and our 3 solution options, here's at least partial criteria that we're going to score, that we're going to weight, and then sum up those weighted totals on a scorecard. And we find something really interesting here with these weighted totals. We have 2 options that score the same. So our people and process solution ends up scoring the same as a retrofit of our existing billing system. Okay. Looks like the biggest bang for the buck is still a new billing system, but maybe we can do something different here. Maybe we can train up the team in a much shorter period of time and at a much lower cost. And maybe we can use the remaining time to build out, while we stem the losses a little bit, and we can use the budget to build a new billing system, which will give us the ultimate gains over time. So now that you are armed with some valuable insight from your trade-off analysis, we actually get to decision time. By now, a recommendation most likely emerged from your trade-off analysis. Maybe a couple of options are close. Maybe there is a clear winner. Maybe you got to something interesting and blended like this 2-solution scenario as you go through it. But now is the time for a decision. You've done the work. You can show your work. You have all the justifications. And by now, you probably know what the right path forward is. So decide on that and go forward. Once made, record your decisions. A lot has been said about architecture decision records, so I'm going to try to be very brief here and not repeat a lot of things. Why are architecture decision records important? This is our last interactive time. I promise. I won't call on you anymore. Capture the why. And then what? Why is that important?
So later generations know why some decision has been made in the past.
And so later generations can know why a decision has been made and do what with it. Yeah. Okay. So it's in part so that situations like that don't happen. You remember the story about 2 Booleans from half an hour ago, so we don't run into this. And remember that architectural decisions affect the long-term cost of a system. The record is actually not important now when you're making the decision. It is important later when those long-term costs start hitting and people start wondering why a particular decision was made. The record is going to obviate that why and help them make another educated decision. They don't have to struggle with why something was chosen. They already have your experience without having to live it. They have what was the problem statement, they have the constraints, the circumstances, everything else there. And their decision should be educated enough to minimize or hopefully eliminate any unforeseen side effects. That's the biggest thing. That's the biggest reason for why is, can they make a next decision better than the first one, the original one? Of course, for any of this to happen, you're going to need to write it down. Have good news for you here too. All the steps got you to here, and if you've been writing things down all along, you should have most of your architecture decision record built up. And I really hope that you've been writing things down all along and not just talking about it. You will need to add a few more things to round it out. One, the actual decision that was made. Two, the reason why you made this decision. And most importantly, what are the positive consequences of the decision that you expect? And what are the negative consequences that you accept? Decisions are always trade-offs. You need to be very explicit about the trade-off that you're making. And maybe those people who start wondering why, they go back to the record and go, oh yeah, this was a known trade-off that we made consciously for reasons X and Y. So wasn't going to show you a template, but this is a cute one. I really like it. You can buy that notepad and use it for life decisions if you want. It comes with all of the right things: problem statement, last responsible moment, trade-off analysis. And it's fun. I think the important thing that I wanted to say here is this decision-making process, the outcome of it is the decision. The record is an artifact. And if you go through the decision-making process and you're diligent about it, the record will happen. But the objective, it's not the objective of it. It is an artifact of it. And now, congratulations. You made a decision. Be confident, stand behind it. Don't want to rework decisions because you're uncertain, and you already have the justification and the record to prove it. You might have made a tough one. You might have gone against popular opinion or your boss's opinion, but in order for development to proceed, you need to fix your decision and move forward. However, there are times when you might need to reevaluate your decision. This last step is conditional, and the condition under which you reevaluate your decision is when material new information comes to light. How do you define material? Material is anything that would have made you maybe take a different fork in the road in your steps 1 through 6. My biggest litmus test for materiality is if I hear something and the first thought in my head is, I wish I knew this when I was making this decision, it's material. That's another very important reason for writing things down, because you can actually go back and look and go, oh, I already considered this before and somebody's just raising it because they didn't like my decision, or this is truly a new thing that emerged that I need to take into account. I recommend going all the way back to the problem statement and pressure testing through every single step with your new information to see if it affects anything and makes you take a different fork in the road. This process should go a lot faster than the first time around. You don't need to be quite as diligent. You already have a bunch of information in place. You just need to use that. All right. And with that, in summary, you now have a framework of 8 steps that, with some practice, will make the process of architectural decision-making a little less daunting. Thank you. I hope all your decisions are easy. If not, I would love to help. I love learning about new teams and new problems, so please reach out. All right.